Joy Semicolons. We're going to be talking about SQL and SQL things. My name is Jason Broccardo. I am a senior system engineer with Glassdoor, specifically working out of the Chicago office. Some of you may know me as Zugu on Twitter and Slack, or Twitter and Mac admins, I should say. Quick aside, my team, our security team, and our IT support team are all hiring in our Bay Area and Chicago offices. So if you're looking, come talk to me. All right, so this is not a deep dive into SQL. This is just a survey, an overview, something to help get you acclimated to all the terms and concepts that are involved with it, so that as you start to do your own investigations into things, it's not all completely foreign to you. I'm a big fan of the see one, do one, teach one maxim, and I've benefited from that my whole life. And so when I started doing this on my own to learn this, I thought this would be good to share because I probably wasn't the only one in the boat who was completely oblivious to what all the stuff was before I started. What got my interest sparked in SQL was dealing with Jamf support. A few years ago, I had an issue. And the ultimate resolution was they gave me an SQL query to run against my database, then ended up dropping some tables, and that sorted out my problem. I was really annoyed that I didn't know why it fixed it. This was sort of this black box. I didn't know what was going on. So that started with a few articles, and the next thing you know, I'm reading books and watching videos to learn more. Like Bash, SQL know-how is cross-platform. It's something that speaks SQL exists on the Mac, on Linux, on iOS, Android, probably your toaster. It's everywhere. It's also sort of timeless. SQL is a standard, and like many things, it was developed at IBM. And that standard has been updated through the years, but it's largely stays consistent. What you learn now should carry forward with you. I have not a database administrator. This is more along the lines of like tinker, tailor, admin kind of thing. And you don't need to be a DBA, a database administrator, to find utility in SQL. I could think it is something good to, it's another good tool to have in your toolkit of things that you use to be a Mac admin. Most of the time, you'll not be configuring SQL or manipulating it. That's something the application developers have done for you. But being aware of how things fit together can help you figure out preference settings and config settings and things like that that you're going to see and have to work with across your fleet. Quick poll, who here has done anything with SQL? Sorry, good, all right. Like I said, this is an overview. Some of you may be more farther down the line than I am, but that's just a level set. All right, under the hood, SQL is all relational algebra and calculus. It's all math. Everything's an equation of some sort that's going on. But it's conversational. It's written in such a way that you can kind of talk to it in English. You ask it a question, it's going to give you an answer. Give you back the information. It is a computer language, but it's not a programming language. So think of something like HTML versus something like Python. It is what's called a domain-specific language. SQL's whole purpose in life is to talk to databases. You get into why databases. Why would you want to use them? And the reason behind it is when you have a large amount of data that you want to work with in complex ways, the best thing is going to be a database. Unlike flat files, a database can hold metadata about its data, which can contribute to how you use it, and the efficiency and speed and performance and everything else that goes along with that. Related to what? They said it's a relational database. Databases are not spreadsheets. It's not 25 columns, but it's actually 5 tables with 3 columns or 4 columns or what have you. And the relationship is how those tables can be connected together across common values. Databases are made of tables. Tables are a structure of columns and rows. Columns are attributes that define a thing, and rows are occurrences of entities. And entities are person, place, minerals, vegetables, whatever data you've defined to be in there. SQL is sorting through all that structure to get data. But we want to go through a few concepts before we get into things. But this is just the general overview. When this SQL statement, which is that thing at the bottom, the select title from, kind of this is what you're looking at if you think about the table structure. So, like I said, few SQL concepts. Schema is a logical structure of the database. It's what's allowed into the database. Where does it go? You'll likely never have to touch the schema, but just be aware it's there. For all the Jamf admins in the room, it seems like every third or fourth update, Jamf does something with the schema, and that's part of what contributes to the delays on upgrade and your database is being upgraded thing, message that you'll see. SQL is built on data types, which are defined when the table is created. Restricting data to a particular type helps with sorting, indexing, constructing, and verifying. It lets the database management systems know how to operate on it, and it's about efficiency. So there's integers, blobs, date, varchar is character, a boolean, true false. Constraints are rules in a database that enforce data types. Things like you don't want text values going into your columns of Boolean data. And constraints usually probably never have to worry about them, but where I've found when I'm messing around with stuff is constraint is what's making the error happen. Like I try to write data into something that wasn't supposed to be there, and MySQL or SQLite says, hey, no, you can't do that. And that's because of the constraint. SQL and databases have this concept of a null. A null is not nothing. It's kind of the lack of something, or it's not the lack of something. The best way to define this is just, a null is a null, but it's not nothing. It's not the absence of anything. It's a null. It's its own thing, but it just might not be anything that you can use or want to use. It pretty much boils down to columns and rows need to have some sort of data in them, and sometimes that is just this mystery value. Many indexes or many databases contain an index or multiple indexes. Indexes, the really one drawback is, especially depending on the size of your database, take up physical space on the drive. But the benefit of them is they greatly increase the efficiency of the database. Indexes create a lookup of a single column. And then rather than searching across, say, 1,000 rows in your database, the database system instead just has to look at that index. And you can very quickly say, oh, rather than looking for Bob across 1 million records, it looks for Bob across one column and says, oh, here's where Bob's at. Maybe the most important thing when you're working with SQL is that character, the semicolon. You can have as much white space, keep hitting return, keep typing into your queries, and nothing's actually going to happen until you type in the semicolon and hit return. That's the terminator. That's what lets the system know, hey, I've reached the end of my instructions, start doing the thing I asked you to do. Select. SQL has a bunch of different commands. Select is probably the one you're going to use most frequently. So there's select, there's create, insert, update, delete, alter, drop, but select is the workhorse. Where, you can think of as like the funnel. Where is the keyword that starts your information sort? And then there are the comparison operators. Equal than, greater than, less than and equal than. That last one here, that's the 2 brackets, that is another way to signify not equal to or is not. The neat thing about the comparison operators is you don't just have to use them on text. These aren't necessarily mathematical things. So, you don't have to just use them on numbers, you can use them on text. It's not just a reserved for mathematical functions. All, and, any, between, exists, and, not, these are things that are called logical operators. They help narrow down or restrict your search. And the convention with SQL is that all your commands and parts of your query are going to be in caps. But that's not the case. You don't have to do that. No system, it's case insensitive. It doesn't matter. It's just something that people have done as part of instruction. Pretty much most everything in SQL will look like this. Like this is the simplest form of query. Queries can get really complex. But this is, they all boil down to some variation of something like this. You're running a command against a particular column in a particular table with some sort of filtering criteria. This is a perfectly valid query. You will get results, but depending on database size, this could be impossible to get through. That asterisk there, the star, that's sort of like a universal wildcard. Like it's going to just pull in everything that it finds. SQL will allow you, when you're searching, to connect together multiple values. So here we're doing select the first name, comma, last name from whatever particular table. And this works across all sorts of different kinds of commands and actions that you want to do. SQL also has the concept of wildcards. So the percentage sign is going to be any number of characters. So I can't remember how to spell Pennsylvania. That should take care of the rest of it for me. The underscore there will be just one wildcard, just a single character. Punctuation matters. Different characters have meaning. Single quotes are used to signify a value. Double quotes can be used to protect things like file paths. So think about like /library /application space support. You need to quote that out. You can use double quotes to do that. If not, you need to escape things. So there's special characters. So say if you have like O'Malley as a name in a database you're looking through, you need to escape out that apostrophe between the O and Malley. And it's the \, just kind of like the same thing as in bash. You can make your criteria, you can combine things through the use of parentheses to encapsulate the particular chunks and sections. You can also use things such as order by, or descending, or ascending to sort your data. To have Z to A versus A to Z, order by, like if this was a group, you could have it ordered by the group. Ascending order is the default, so you're just by default that's what your returns are going to look like. You can also have that based on a particular column. Distinct is a keyword which will cut out duplicates in what's being returned back to you. So if you're searching your database for Adobe Photoshop, like in JAMP, you can have the applications database. You've got 500 instances of Adobe Photoshop 5. You can say just return to 1. Well, it's that. The limit by, you can limit, think of it like head or tail in bash. So we could say, hey, just give me the first 5 or the first 10 or what have you. Things like that come in handy when you're searching through stuff and you don't necessarily know what's there, you're doing some exploration. Rather than have it return a huge chunk of information back to you each time, you can limit and play around with it. Aside from returning data results, SQL can also look at the metadata. So you can do like, give me the count. So how many machines are in my database if I look at the cross, do a search across computers. You can do sums and averages. You can also concatenate different columns together. So like, early example is up there, it's a first name, comma, last name. We could create that, concatenate that into a new column that just be called full name. Most of what I said we're going to do is talk about is select, so just querying, just like, hey, give me the data. But there is the concept of you can update, add things into your database. And so that's always the update command. Update and set, which is sort of this keyword, always go together. Updates modifies things in a column across a row, or not across a row. And this is how you can change data without having to remove it and re-enter it. So you don't have to like delete and replace, it just update it. In insert statements, excuse me, sorry, I lost track there. So the insert statement is, once again, this is how you introduce fresh information, brand new information into your database. And you can have, see I've got here column A, column B, and then the values match. And so it's it's going to insert key 1 into column A, key 2 into column 2 based on how it's presented there. It's important with your insert values that everything is single quoted. The delete statement works exactly the same way as a select statement. And in fact, you can actually use a select statement, like write your select statement as a test, see how it works. Does it return back the things you want to remove, and just swap out select for delete. And then it's going to remove those things from your database once you run it. There's other things, altering your table, going in, changing the name, changing the column structure, and then dropping, which is completely removing it from the database. We're not going to get into today, but you're probably going to run across those things as you work with it. SQL has a concept of keys. There's the primary key and a foreign key. Primary key provides a way to uniquely identify a row, identify a row in a single column, and a way to identify data from one column to the next. Usually think about this, you've got a database of students. Every student has a student ID that is unique to them. There might be two kids named Emily Smith, but they're going to have different IDs. So that is their primary key. Foreign key is another table's primary key. So when you're doing queries, you might need to reference the foreign key in another table you want to connect together with the one that you're searching through. When you are referencing multiple tables, you're going to need to use this dot notation. So it's going to be the table name dot the column. And so you could have two tables, film and actor. And so you've got, in the film database, it has a column called actor. And in the actor database, it also has a column called actor. And so it would be film.actor, in actor.actor. MySQL also has the concept of aliases. You might want to use an alias to, your internal database name means something to you, but doesn't necessarily mean something to someone else. And so if you're using this to generate a report, or say you have a value that you don't necessarily want to share with others, you want to obfuscate it for some reason. Also, like I said, we could have concatenated names. We could take last name, first name, put those together for a full name. You can use the alias. It's just it's the command, and that allows you to temporarily and not permanently change the name that's going to be presented for a column. Subqueries is a way for you to do a search and have that be the criteria for the next search. If you're, once again, for the Jamf admins in the room, if you think about when you're building smart group criteria, you can have those use the parentheses, same idea. So you have the interior criteria that you're doing, find me all the MacBook Pros, and then you're going to search the broader, that's going to be the criteria for the larger search, which is, model, 2019. SQL has the concept of joins, and they are the embodiment of the relational in relational databases. Joins link together tables across a common value. The connection is made between the primary key and the foreign key. Joins are not permanent. They exist only at runtime when you run that query. There are a couple different kinds of joins, but the one you're probably going to use most is what's called a just plain old join, or it also can be referred to as an inner join. This is the basic syntax for a inner join. So we take we select the first column from table A, and we want to join on column B, and you're going to match up this column in column A and this column in column B. Here's another view of what I was just saying to get a little bit more specific. So you can see we're looking at the admins database, and we'll pull a name, and we're looking at because what we want to do in this search is we want to find all the admins in their company based on who's speaking. And so we could search for that, and we're looking for Greg Eagle. This is roughly what an inner join looks like. So an inner join is going to take all of the items from the first table and all the items from the second table that exactly match, and return that as your result. A couple other kinds of joins. You have the left outer join and the right outer join. These two come into play more when you're dealing with more than two tables. So if you've got 3 different tables of information, and what you're looking for is spread across those 3, you can use one of the outer joins to get that information together. I also consistently find ways to screw these up, so I will not be demoing them. This is roughly what an outer join looks like. So it's just taking, and the terms left and right come from where the database, or excuse me, where the table is mentioned in your statement. So it's on the right hand, is the first one called, or is it left hand, the second one called? Right outer joins should return everything in the right hand column that exactly match anything in the left hand column, but nothing else. Conversely, this is what a left hand join would look like. We don't need to get into it too much, but you might hear this term is ACID. ACID is based on transactions, or related to transactions, I should say. as far as a database is concerned, a transaction is a set of instructions that all occur together or they don't occur at all. You trust that the thing happened in the way you intended. Asset compliance is a way for a database to say transactions are happening as they're supposed to. Think about this, databases first used in finance, a bank needs to store customer records, account information. When you have a transaction go through, you want to make sure that it is processed correctly, otherwise the bank is out of money or the customer is out of money and then it causes problems. SQL has the concept of normal. So if you're reading about database design, you're going to see this concept introduced and gone into. Normalization is, there can be different levels of normalization. And it's all boils down to having your data organized in the most efficient way for the database to optimize its searchability. All right, let me get out of this and hopefully we keep our video. Hang on, I've lost my screen. Give me a second. Is this everything? All right. Is that viewable? A little bit more? All right. Hey, there we go. All right. Am I going too fast? No, all right. So, going to go over some just basic SQL stuff before we go on. Just make sure we're all kind of in the same place. And rather than listen to me talk about it, you can kind of see it in action. So we can look at the databases that I have here in my system. I don't want to do it too much because stuff is going to start to get cut off. Is that okay? Okay, cool. So these are all the databases have on here. You can have any number of databases. It all kind of just depends on the power and storage capacity of your system. So this is a pretty simple database. It just has one table in it, directors of Space Force. What we can do is, I'm using MySQL for this. Other database systems, which we'll go into talk about in a couple minutes, but other database systems, the commands might be a little different. In MySQL, you have the describe command, and so we can say, tell me information about this table. And so we can see these are all the potential columns that are in it, director number, first name, last name, mission count. We get that type is the data types that I was talking about. So it's an integer, it's variable characters, it's a date, whether or not it's allowed to be null. That key up there on the director number, that's signifying that is the primary key for this table. So director number is always going to be unique across any entry in it. And here, let's do. So, like I said, basic table, or most basic search is just, hey, give me back everything. So, select .star from directors. But then we can say we want to see. Let's try, order it by the last name. So that we can order by the last name. This is where you can get into, you can have your returns sorted in particular ways, pretty much however way you want it to do. this is an example of selecting different criteria. So rather than pulling out everything across all the columns, say just give me the first name and the last name. So select first name, comma, slash last name. So I name those two tables in there. We can do since that is a word, I had to put in single quotes. If it was a number, you wouldn't have to worry about that. If I should say, let me rephrase that. If the database considers a number, so if it is data typed as an integer, you wouldn't have to quote it. So we pull up just that particular record that matches the criteria we were looking for. Like I said, you can also have those logical operators. Whoops. Hey, I forgot my semicolon. That's what that means. Hit that. It's found all of the last names, which is what I was looking for, which were greater than K in our listing. So that's why I pulled up Malone and Whittle. We can also do the wildcards. So it pulled up the one record that matched where I was searching for the last name that started with K. And then I didn't know the rest of the characters. That's what the parentheses in there is, that wildcard. And then we can come here and, hey, complex, I want return the name of every director that has a mission count greater than 10 and where mission success is greater than 2. And so that's what we get. So this is an example of both the concatenation. So we're going to combine the first name and the last name fields. And we're also going to alias that. So it's going to be, give it to us as the full name. So this I was saying, on the fly, this isn't a permanent change to your database, but on the fly, you can change how the information is going to be presented to you. Sorry, I'm blind. I can't read that myself. Once again, we do another search. We can combine a few different things here. So concatenation, the aliasing, and then we have multiple search criteria that we're using. Like I said, you don't have to just have a return of data. You can have a sort of the return based on metadata. So this is just give me the total count. So if how many machines are in my Jamf system, do the star count on the computers table, and hey, it's going to tell you got 435 or what have you. We can also, like I said, we can do a sum. So here we're going to give me the sum of what's our total amount of missions. So we've done 79 missions that all the various directors have been responsible for. And it's strictly, select sum, which is the function, and then the table that we want to add up. Now, if we wanted to insert data, new director we want to put in here, this is what the insert statement looks like. Insert into which table? Directors. Parentheses, all those are all the tables. If we wanted to, I'm inserting information into every table, but if you wanted to have, you're going to insert the first name and the last name, because that's all you knew at this time. It would just be parentheses, first name, comma, last name. And then in the values section, we're getting cut off here. I can't make it all be on one line. Once again, those are in parentheses, and all of the information, the values that we're putting in are in single quotes. If we want to have a blank there, you would just do comma, empty quotes, quote, space, quote, and leave that, and then another comma. But here, in the way you're supposed to do it is every value matches up with the column that it's going to go into. So Gallagher, last name, term starts, term ends, and so the order of the values is the same as the order of the tables that I have it here. You don't have to do this in the same way that it goes in the database. That's why you have this here. You're just telling it, do it this way, enter it that way. And so edit that in, and if we and hey, Fergus Gallagher has been added in here. And the system, because of the way the database is configured, automatically gave it a new ID number, because that is an auto-incrementing field. That's something you can have set up when you create your database. That will automatically increment fields. Since we're using it as our key, that's a good thing. We want to make sure that's always going to be a unique value. So right now, Director Goldbig here has no successes, but we can give him a success. Oops, I've missed part of that. So the update statement, update, what we're going to update directors. We want to set mission success, which is the table, new value 1, and specifically where the last name is Goldbig. This is an example of, like I said, white space doesn't matter. You can hit return and space and whatever you want to, and until you put in the terminal, which is the semicolon, SQL is not going to care. So now, that mission success has been increased. Let's see. Pass that up. This display is out, so give me a second. I gotta. There we go. Any questions about what we've covered so far? Cool. All right. So relational database management systems, often referred to as RDBMS. RDBMSs are responsible for the structure of your databases and how data is stored and how the databases are indexed. RDBMSs govern how you interact with data, how it's ingested, how it is exported. They provide you an interface of some sort to the data. If it's a bit of a stretch to, say SQL is like HTML, or if you're comparing, SQL to Python, different kinds of computer languages, then you can think of an RDBMS as kind of like a web browser, if you're comparing it to SQL to HTML. There are many RDBMSs. We're only going to talk about 2 today, MySQL and SQLite. If you use Universal Type Server or SAL, both of those use Postgres SQL is the backends. If you're in some place where you're using Microsoft SQL, MS SQL, be aware that it uses its own variant of SQL called TSQL. It's a little different. Some of the commands are different, and how you do queries can be a little bit different. It's mostly the same, but Microsoft being Microsoft, they had to make it a little different. So MySQL runs on pretty much anything, Linux, Mac, Windows. Many applications depend on MySQL as their backend. MySQL, like almost all of the RDBMSs, except for SQLite, operates in a client-server fashion. SQL is still open source, despite being purchased by Oracle several years ago. Though after that purchase, you had forks developed, and so you'll hear of things like MariaDB or Drizzle. Most of these are usually just drop-in replacements. Most things you can just drop in MariaDB for MySQL. It just kind of depends on your application. If it needs something specific from SQL, you might have some issues there. Though MySQL will run on pretty much anything, having it run well is another matter. Depending on the number and size of the databases that are being served and number of clients that are connecting to the service, you might need to increase your hardware resources. CPU matters. Remember, there's a lot of math that's going on in the background. Memory allocation can make a difference. Disk read and write speeds can be a significant factor. MySQL maintains its own set of users. The MySQL users are not the same as the system users. So you have root on the system and root in MySQL, two completely different accounts. You can also have users that are specific to that machine, which is usually referred to as at localhost, or remote users, and so they'd be identified as at a particular, coming from a particular IP. Grants are MySQL's permission scheme. Grants define what a user a MySQL user has access to and what actions they can perform. Grants can be really broad, like, hey, this user has grant everything, or you can get really granular. So like, this user only has access to these tables and can only perform select operations. So that's how you can have, like safety sake, security sake. You can have users who can only do selects, and then other carefully defined users that can do updates and drops and all that sort of stuff. Storage engines are a component of MySQL. And as far as I know, they're specific to MySQL, but the concept is storage engines govern how data is managed and stored by the database. Storage engines are akin to kind of a file system, in rest of computers. Storage engines are responsible for things like file and table locking and how files are physically written to disk and how the indexes are created. There are several different storage engines with MySQL, but the most common is the old default, which is MyISAM, and then what's been the new default, well, new for the past few years, is InnoDB. It's INOODB. For all the Jamf admins, if you run on-prem, that changed with the database, came in with Jamf Pro 10.6. InnoDB should, going forward, provide better database performance. MySQL includes an administrative tool, MySQL admin. MySQL admin can be used to run command line instructions to administer and service the database. Depending on the circumstances, MySQL likely really only have to use it when you're trying to troubleshoot something. myconf is the primary configuration file for MySQL. Depending on which OS you're using, it's going to be in a different place. Usually it's in Etsy someplace. If you're running MySQL 8 on a Mac, like I am here, there is no default configuration profile for some reason. There are numerous options in the configuration profile that you can have. I want to highlight a few that might be relevant to Jamf admins. And this really only matters if you're hosting on-prem. If you're Jamf Cloud, you don't get access to the database at all. So max connections. This is the total number of incoming connections to the database that will be supported. Rule of thumb is usually to set this at the number of web apps times your max pool setting plus 1. Max pool is a Tomcat variable that you set on, in your Tomcat settings. The default is usually 90. The plus 1 is to give yourself an out. So if services go nuts and your database has been flooded with requests coming in from Tomcat, in theory you should have that one left, the one connection available that you can SSH in and kill stuff. Table open cache. This is how many open tables, but not opened, because that is a measurement of things over time. But this is just how many open tables. I can't give you a hard and fast recommendation for this because it's all relative to how many Tomcat web apps you're hosting. It's a bit of a guesstimate. This might be something that you run your server for a bit of time and let it do some burn-in, and you make observations, and then you go back and tweak that setting. The value of table open cache impacts several of the other settings, so it's an important place to start. The first one up there is from the official documentation. That's MySQL's recommendation for what to set for table open cache. The problem is, like who knows how many joins are going to be in any SQL or Jamf query, especially because Jamf, at least its version 10, has at least 430 tables. Number 3 there is you got to do some observation on your system and do some queries and kind of see where it's at. end of my talk, I'll have a link that goes out to a Google Doc, which includes a cheat sheet that I came up with, and it has a couple different ways to get through this. Open file limit. This is generally going to be the multiply your table open cache value times 2. Open file limit is just that. The table definition cache, this is a setting that helps speed up the opening of tables. And so you usually do table open cache divided by 2 plus 400. Once again, all these formulas are in the cheat sheet, which is in the link. INO buffer pool size. This sets how much memory INODB can use for the in-memory cache. You want to give INODB as much memory as you can spare. The rule of thumb is usually 80% of available memory, but keep in mind it's 80% after you've subtracted memory for the system, memory for MySQL itself to use, memory for any other services you're running on the box. And you probably want to throw in a little bit of overhead, like as a fudge factor. MySQL, takes the whole database concept to the extreme. Everything inside of MySQL is another database. User information, running configs, performance specs, all of it can be harvested out of the MySQL and sys databases that are in the system. And so let's pop out and take a look at some of that stuff. I've got this fancy touch bar, but it's not giving me the buttons to do mirroring or not mirroring. Is that it? I'm pressing function. Well, whatever, I'll just do it this way. All right. Same screen, yes. All right. Readable, or do you need to increase it? Okay. All right. Actually, let me show you that first. What's really handy, if you look at an SQL backup file that MySQL produces, I think other systems do it in the same way. But if you open it up in a text editor, which depending on the size, you may or may not be able to do it. Obviously, open up a 6 gig backup in a text editor might cause problems. But if you can scroll through, and the backup is essentially every entry that was done. So you can look at how the database was created, how the information was entered. It's really handy when you're trying to take something apart. So this is another system I've got. And telling it I want to use this particular JPS database. I've got a JSS running on a VM here. And we could say show tables, which is command in MySQL. Other systems have different commands. But show tables, we're going to see every 442 tables that Jamf has by default in a 10.12 version of the Jamf Pro software. So let's see. Actually, before we get into that, let me back up here. I went the wrong way. Oh, damn it. I don't know why, but in this VM that I made, I can't sign into MySQL as the regular user. I got to go through root, and there's a delay, but it's a VM that I set up for demo purposes, so I'm not going to spend too much time trying to figure it out. like I said, you can use MySQL admin to run queries against MySQL, not queries, excuse me, well, yeah, queries, but not the same as regular query. We want to get some status information about our system. This password is going to be specifically the MySQL root password. Remember I said it has its own set of systems. So we could see, this MySQL service has been uptime, how many queries have gone through, how many tables are open, things like that. When I said, some of the myconf configuration settings, with table open cache, you might have to do some observations. This is kind of a place where you can start. This was stuff like this. You can also do that within, log into MySQL and start to get information in similar ways. Like I said, everything is a database, so we can search for particular values. So we can check the configuration within MySQL by doing a search query against it. If we want to find out how big are the databases, we could do something like that. And so we'd come back and we say, oh, hey, our Jamf database is 17 megs. It being Jamf real life, this would be like gigs because Jamf is not always the most efficient with that stuff. We can see things like the memory allocation per process. So now I go back. So a couple practical things. If you're a Jamf admin, thing to keep in mind is Jamf, the database is Jamf's. You don't really want to go in there and make any changes, but it doesn't hurt to query against it. You can go and pull information out. You're not going to hurt anything. And sometimes you need to. Say if you wanted to generate a list of all of the administrator users on your machines, you could do a query like this. And so it's going to search across your Jamf inventory and pull up, hey, these are all the admin users. You can do the same thing inside of Jamf, but say like you're trying to combine this with other information, you could do that. One thing that's kind of hard, or might be hard, is, hey, I want to find all of the machines in my system. I need to use a different database. You could do that, and that would pull up all of the machines that have a blank serial number. You see that a lot where a machine has gone out for repair, logic board gets replaced, Apple forgets to do the blank board serializer, you get a machine back that has a blank serial number. I need to switch databases here. Another one that is also hard to do inside of the Jamf is you can have machines get enrolled at different times, and if something about that machine changed, such as the logic board was replaced, you can end up with a machine with the same serial number being listed twice. So a search like this would give you a return, and so then you could then take these serial numbers, go and look in JSS, figure out which was the last one, the old enrollment, and get rid of it. All right, this is only a slight exaggeration. SQL-Lite databases are everywhere across macOS and iOS, and presumably iPadOS and tvOS and watchOS. If I run a search across my home folder on my machine, I can find 1,600 SQL-Lite databases just within my home folder. Why are they using databases? If you recall, it's because if you've got a large amount of data you want to deal with and work with it in complex ways, databases can be your best solution. Plus that data can be indexed for quick returns. These databases are constantly being updated and hold different types of data beyond just sort of key value or key pair values. It's more efficient to have it in a database. If you think of a flat file like a plist, that can have information in it, but think about like the process of updating a plist, especially if you have something, say like your Safari search history, that's constantly getting updated, and it's just not going to be efficient, and it's going to be slow. But why SQLite? And that's because this is what SQLite is made for. SQLite is a file format. It is also its own storage engine, and it is a library that can be used by other applications. The SQLite motto is small, fast, reliable, choose any three. SQLite is different than the other relational database management systems in that it is file-based. There is no server. And though it uses SQL syntax for queries, its commands are different. They all start with a dot. And so a few of them that are worth knowing, we've got .open. This is how you get into an SQLite session. It's usually .open, whatever the SQL database you want to open. .schema is the equivalent of MySQL's describe table, or describe table name. This is .schema will show you how that database is constructed, the tables and data types and things like that. .tables is the equivalent of MySQL's show tables. It's going to show you all of the tables in the SQLite database. .dump is just that. It's going to spit out everything that's in the particular database. Usually you can start with .dump to help you start investigating something, but it might be just a completely unmanageable return depending on what's in there. .mode is a way to alter how the information gets presented to you. Probably the ones you're going to use most often is you would do .mode and then line, or .mode and list, or .mode and CSV. And so that governs how the data gets shown and presented to you. SQLite also has an option called .excel. And what this does is this opens up in your whatever is defined as your spreadsheet application of choice in your system, a temporary in-memory only export of your queries. And so you can do .excel, then you run a query, and it's going to open it up as a CSV file automatically for you. It doesn't actually exist, it's just temporary. .output and .once. If you do .output and then start typing queries, all of the queries that you type are going to go to wherever file path you defined. So like you could start a session, start doing a bunch of queries and searches, and all that's going to be saved to a text file. .once, we'll just do it once. So like you do .once and then enter your query, and it's only going to do that query that immediately followed it will get written out. And then .backup, it's handy. It's, the convention is just .backup and then the table. It gets saved to the same directory that the database file that you're looking at is in. So say if you do want to start making changes, maybe do a backup first. What's neat about SQLite is that you don't have to be in it to run queries against the database. So this makes it very handy to script it. Think of something like extension attributes for Jamf, or to put inside the modules for Monkey Report. So you want to get some data off your machine and get it into another system. You can do SQLite queries. The convention is, SQLite, the binary, what database are you looking at, and then within single quotes, your query you want to run. If you have a value inside of your SQL query that has spaces or something like that, you'll probably have to use double quotes to do the proper escape inside. Like I said, like within my home folder, there's 1,600 SQLite databases. There's tons of them all over the system. How do you find these on a particular system you're looking at? Start thinking about where the OS, think about how the OS keeps files on the system. Where are preferences and configuration settings usually at? You're probably going to find some databases there. Some of them are obviously named. They're all, .db or .SQL data. You can also look for these files called WAL and SHM, which I'll explain in a couple minutes. Sometimes the names aren't obvious. So you can just search for, hey, give me back everything that ends with .db. But sometimes the names aren't obvious. And so you can, MD-find can be your friend, and we can look for the particular data type. Database document is the tag that Spotlight uses for SQLite databases within OS X. But then sometimes, and I don't know why, databases aren't tagged with any information. Like MD-find won't find them, They don't have obvious names. So you can run file. So you do like file, whatever it is, and it'll tell you what type it is. You can open up with cat, and you'll see at the very top in the header information it say SQLite. You can also just try and open it with SQLite and see if it opens. It's not going to hurt anything to try. The wall in the shim files, wall is the write-ahead log. It's basically a safety valve. Changes are written to the wall file, and then only after commit has happened are those changes then committed to disk. Shim is shared memory. It's what holds SQLite indexes. When you're going to start to, if you're using SQLite to explore different databases, you could just, .dump everything, but that gets kind of messy. Usually what I do is, do .tables to see what tables are there, and then do .schema to see how things are laid out, and look for data types like var character and stuff like that. And then you can also construct your search query, select the table name as key, then limit like 5, something like that. So like use the other SQL options that you have to kind of condition down the information just to make it easier to sort through. The other thing that I've learned is that no one at Apple can agree on what time it is. There are currently 6 different time systems across the OS, and you'll see these in different databases. So there is the traditional Unix epoch, there's the Mac OS epoch, then we've got the more current Cocoa one, which corresponds to when OS 10 first came out, plus a couple other ones. So it's something to keep in mind when you have a time value that gets returned to you. It might not be the time that you think it might be. All right, so we're going to play SQL Lotto. Give me a second here. Who did I say was F? Is it? Never mind. I'll just do it by hand. All right, give me a number between 1 and 26. All right, hang on. 24. 24? All right, give me a second. I usually do sudo with this stuff, just because depending on what we're going to be looking at, you might need access. The other thing to keep in mind is that Apple is restricting stuff more and more. I know with the current public beta for 10.15 Catalina, some of the searches of things that I've done that are buried down like VarDB are restricted now. They're SIP restricted. So in theory, you could boot to recovery mode and do it there, except SQLite is not in recovery mode. So basically, if you really need to get something out of there, boot to recovery mode, copy the information off, and bring it to another system to investigate. All right, so I heard 23 was the first one. Let's see. Oh yeah, so this is not necessarily going to run here, but I'll show you. I had an issue at work, how do I specify a user, where we had we're a Zoom shop, and we deployed a bunch of new Zoom controllers in the rooms. They were all handily named Zoom's Mac Mini. And so I couldn't figure out a way to, I needed a way to what is the problem here? I needed a way to figure out what the machine was called in Zoom versus what it was actually called. And so I came up with a query like this to do that. Hang on, let me just get in here. I think it doesn't like that. Oh, actually, that's the problem. This file does not exist on my machine. But that brings up stupid Zoom. Give me another number. Hopefully we'll have a search I can actually do. What was that? What was that? 22. 22? All right. So I have Mac ports installed on here. You might probably be able to do something similar with like Homebrew, but I can pull up a list of all of the things I've installed through Mac ports just by searching against their database that they have. Give me another number. 13. 13? So, What is the current user's image that they're using for their desktop picture? We'll do one more. Give me a number, please. 14? So that is a listing of all of the accounts that I have configured in System Preferences accounts. So this is, like I said, there's information like this is all over the system. You know, where I've found I've been using this is for EAs. There's some particular data or bit that I want to have off the machine in our Jamf system that's not necessarily reported on by Jamf. So you do things like that. Like I said, I've got a bunch of these queries here, and they're all in the doc that I'll share at the end. You know, here I'll just show you one more because TCC is so much fun. Those are the applications that have you know, access to the system files. So that corresponds to up here, System Preferences, Security. Where's that at? It's not full disk access. I forget which one of that. It's one of the TCC options, but those are the ones that have been granted access to it. All right, OS query there's been a couple different sessions last year. There's a couple different sessions this year about it. It's pretty much for, you know, when you want to go full hog with SQL on your computer. OS query was developed at Facebook, and it is essentially allows you to do SQL type queries against your system to pull up information. And here, actually, let's do a couple of those. So, for instance, I could use OS query. Let's get in here. You know, if I want to find all of the non-Apple things that I have connected over USB to my system, such as this SanDisk drive, I can use OS query to pull that up and look at it. We could also, you know, I can use OS query to say what wireless networks has my machine been associated to at some point. But yeah. So it's, like I said, I just wanted to touch on OS query. We're not going to go into it. There are much better presentations. Lucas Hall gave a really good one last year, and Wasserman, I can't remember his first name, who was with Collide, gave a pretty good presentation on OS query here last year. How can you practice with this kind of stuff, if, you know, without blowing up your production system? What you can do is there are a bunch of, well, not a bunch, but there's a handful of databases that have been written either by the folks, the MySQL developers or other folks that are available on GitHub and other places. Be prepared, it's kind of like time travel because they're all dealing with video stores. Or the other thing that I've done is you can take one of your, if you're a Jamf admin, you do those nightly or weekly backups of your JSS. You can take those SQL files and import them in and then work with them locally on your machine or wherever. You're not touching production. You're not going to damage anything. It's not going to hurt anything. And then there's also, like I said, all of the SQL-like databases that are all over your machine. This link is the one that I mentioned. If anyone wants that address. And that, let me just bounce out. So in there, we've got, pretty much any query that I mentioned in here, plus some other ones that I didn't. I have a cheat sheet of stuff that I've made for myself that I've shared out, things related to MySQL, including those configuration options I was talking about, and stuff for Tomcat, recommended books, articles. This last one here is about the Apple time things that I mentioned. There is a security researcher named Sarah Edwards. She's developed a system called Apollo. where it's a script system for taking databases and then pulling information out of them. So a lot of that stuff that I was talking about, where you can search on a system in SQLite, the databases, she's kind of built a framework to make that a little easier. She's primarily concerned with iOS stuff, because she is she works for presumably one of the 3-letter agencies. She works in law enforcement of some sort, and so she's doing like forensic investigations. But yeah, she's got, it's neat, and her talks are pretty interesting. And last, thanks to Golby for being a good sport. Any questions? All right, thank you very much.